Okay, so in this video, I'm going to try to set up an enemy for our game. So, unfortunately, my second dual screen isn't working too well, so I can't really reference code and go back and forth. So I have two Eclipse windows open, and if you see me jumping back and forth, try not to freak out. Because there's a lot of things we got to get done, and I definitely need to reference code for this video. So, the first thing we're going to do is we're going to go to our characters package, and we're going to create a new class, and I'm going to call mine Ice Cube because that's what my character is going to be. And he's going to extend the thing class. Now, if the AI class was working in the engine, we would use that and we would extend that. But unfortunately, that's not really an option for us right now. So we're going to go ahead and add our constructor and our unimplemented methods. We're going to get rid of these two things. Even though we're low on time, I always get so annoyed by those things. Okay, so we are going to use our destroy method, and we're just basically, when we destroy something, we're going to remove it from our stuff array. And so that's really simple. And then we're going to put it at the bottom of the class because we're never going to look at it again. Next we need to give this a sprite. And we're going to import our sprite equals new sprite. And I guess I do need to set up the images. I was hoping I wasn't going to have to do that, but I think I do. So we're going to go to main, open up our loading manifest, and yeah, I haven't done it yet. So we're going to add this reference ice cube, and then we're going to go down here and say ice cube equals new ice cube. Alright, sorry, no. What am I doing? That is so stupid. Okay, loader dot image loc dot images plus, I want to say it's ice cube dot png. I'll have to check in just a second. Capital C. So hopefully that loads okay and we don't have to come back to that. Okay, so now let's go to lm.icecube, and there's our image. Now we need to set our mask equals new mask. This 0, 0, width is sprite.xscale times sprite.getWidth and sprite.yscale times sprite.getHeight. Okay, so we got that set up, and I'm going to check my reference again because there's a lot of stuff we have to get done in that class. Okay, so the first thing we want to do is we're going to go ahead and set up, we're going to say sprite.step because that's really important and we need to render our sprite. Okay, so we are not going to call the super.step because it's not going to do things in the correct order, because eventually we want this ice cube to follow a set path and we want him to also have to deal with gravity and stuff like that. So what we're going to do is we're going to say x plus equals dx and y plus, and that's just going to convert our speed into position, and everything else we do is going to be in between here. So let's add this to our panel and see what it looks like. We're still not finished. We got a lot more to do. I'm going to say new ice cube, and I really don't care about the position right now, just somewhere on the frame, somewhere in the map where we can see it without doing a whole lot of work. So there's our ice cube. He's just kind of sitting there, not really doing much. So now we need to give him gravity. So gravity is pretty easy. I think we did it in the blob class as well. Super.gravity. So we're going to call that method. And he's going to fall straight through the block. Because now he needs to be able to make collisions with the block. So the way I did this ended up being so strange. And I gotta reference it again because there's a lot to do. Yeah, it's really annoying. So we need to set up a block collision method. And I'm really just gonna copy and paste it from my reference. And then I'll explain what's going on. And we're only gonna look at this once. So basically, what's going to happen is when we collide with a block, this method is going to be called after the basic collision is handled, and then we're going to do this, and let's save that for later. The next thing we need to do is we're going to open up our steel class, and we are going to override the step method. And this is, there is so much work we got to do to get this set up. So we're going to set up the for loop that's going to go through every object in our array list. Oh, sorry. Dot size. What am I doing? So it's going to go through all of our objects, and then we're going to check if gp.stuff.get bbb, I spelled get wrong, instance of ice cube. So if our object is an ice cube, we are going to do some extra stuff. So then we're going to say if, and I'm going to check this code again, because this is where I had issues. And I think I'm just going to copy it and then explain it. I'm really sorry, guys, that I don't have a second screen, so I'm not really comfortable trying to do this, because it took me a long time to get it right the first time, so I want to make sure I give you guys the right thing. So what's going to happen is every time it's an instance of an ice cube, we're going to check this mask and see if it's colliding with the mask of the ice cube. And if it is, we're going to get all the different sides. What this method does is it returns an array, a Boolean array of sides, and if it's true, then that side is the side that's the collision is occurring on. And if it's false, it's not. And I know that sounds really weird, but it's important. So then we'll go through a for loop, and we're going to say if sides is true, so we're going to find what side is true, and then we're going to call this method called block collision that we just created in our ice cube class, and then we're going to tell it what side it's colliding with for the block. And then we're going to call collision, which does your standard block collisions and stuff. So that's going to handle a lot of everything. And then in our ice cube class, we're going to get our side of the collision, and then we can check what side is touching the block, and I'll get into why we need this later in probably a couple minutes. So if we were to run this now, it should collide with our steel block and stop. And it is. Now you see how there's a little space in between the block and the ice cube? That's because when I drew my image, I didn't do it perfectly, and so there's a little bit of space in between the ice cube and the bottom of the image. So what I'm going to do is I'm going to change the height of my mask, and I don't know about you guys, but I'm getting really tired of the screen recorder cutting off on me. But so to change the height, I'm really just gonna, subtract 2 pixels, because that's probably what we're gonna want anyways. It's only gonna be 1 or 2 pixels, and I think I got it exactly right this time, which is pretty rare. So with that handled, the next thing we need to do is get our block to follow a path. Because right now, it's a computer. We want our AIs to move, and that makes it a little more challenging in the game. So this is when it gets even more complex. So I'm going to copy and paste another method from what I made earlier, because it's actually a pretty big method and it took me a while to get it working correctly. And so it's annoying. So we're going to put this under our block collisions, because again, once we do this, we're not going to use it again. So we need to import our rectangles, we need to import our points, and so we also need to set up an H speed. So I'm going to go up here and I'm going to say private double H speed. And I can't remember if I gave that a number or not to start with. Let me check. Again, this is why I have references, because this is actually kind of hard to do, and I've spent a lot of time doing this. I've done it a bunch of different ways. Okay, I'm going to go ahead and copy this so I don't forget anything. Sorry if this is not turning out to be a very good tutorial. So we need a private integer jump num, a private static final max jumps, private double jump speed, and private double H speed, and you can give those any values you really want, except jump num needs to be 0. So, and I'll tell you guys how this works. So basically, we're gonna give this a point, and it's gonna move to that point. Now, it's only gonna look at the x coordinates to find out if it's reached that point. So if this x is equal to the point x, then we're going to set it equal to 0 and we're going to return true, because that means we have moved to this point. When it returns false, that means we are still moving to the point, but we haven't reached it. If it returns true, we have reached it. This is really a really big mess. And basically what this means is if we're really close to the point, we are going to slow down. Because if you go too fast, you won't hit the point exactly, and then this equal sign is not going to work for you. So you have to slow down at a certain point, which is when you get less to 8. It's complicated. You guys can probably look at it and break it down and figure it out. And then this is, normal stuff. And then our jump method. So we need to make this character jump just like as we did with the AI. And so I'm just going to go down here and make our jump method public void jump. And since this is an AI, and you could probably extend this class to make other enemies, what I'm going to do is I'm going to say if jump num is less than max jumps, and our max jumps is a number that we set earlier, and you can change for different things. And then we're going to increment our jump num, and then we're going to say dy equals negative what was it, jump speed? Yeah, which is also something I defined at the top. One of those things we copy and paste. And if you need more time to copy this method, this would be the right time to do it. I'm trying to get it so you can see the whole thing at once, but it's just too big. Pause the video right now, copy what's on the screen, and then pause the video again and copy this, and you can figure that out pretty well. Anyways, so now we have our jump method, and he's going to jump when he reaches that point. And then I'll explain this later. So the next thing we need to do, now that you guys have copied all that code, is we need to change this. So we need a private point, a start point, and an end point for the path that our AI is going to follow. And this is a really, really simple path, and you can probably alter it so you can go to more paths and stuff. But basically, we are going to, hold on, which way did I do this last time? I think I did it, okay, yeah, I do like it that way better. So we're going to change this to start X, start Y, and then we're going to add two more, integer and X, and integer and Y. And then this is going to be start X, and this is going to be start Y. And then we're going to say start equals new point start X and start Y, and then the same thing for the endpoint. Not sure why. Oh, Eclipse is just being buggy. And X and Y. So that's how that's going to work. And then over here, this is going to be how we control moving from one point to the other. And actually, we have to add another variable, private integer index equals 0. Because we're going to use this. Index is going to take care of things. And actually, let's change that to path index. Make it a little bit more readable in case you want to call something else index. So if path index equals 0, then if move to, so if we're at the index 0, then we want to move to the endpoint. And then if that's true, we want to say path index equals 1. Else, it does help to spell it correctly. If move to start is true, then path index equals 0. And so this will keep our AI moving back and forth in between the 2 points. I think. If I did everything correctly, it will. Well, I still have another thing to do. We did not set our points. So we need to whatever. So we need to make our new ice cube with the new parameters. And I'm gonna go ahead and say 50, 50, and then we'll go over 150, 50. And again, remember the y's don't make a big difference. And the end y really isn't that important. In fact, it's really just the start y that's important. So now we're going to make sure it works, and hopefully it does. And there we go, we're moving back and forth in between the 2 points. Now what if I made that path go down here? Which would probably be 350 just to be safe. There we go. And now he's stuck on this little block. So that's when the little block collision method comes in handy. Sorry, wrong class. Ice cube. Because what happens is whenever we're colliding with the right side of a block or a left side of the block, we want our AI to jump. That way, he's not going to get stuck like that unless he can't jump high enough. Sorry, that was my screen recorder going out again. And we're still not quite done. There's a lot of stuff that goes into this, and this is probably the most simplest AI that I'm working on. So you can tell he hits the block, he jumps, that's good. Goes over here, and he's stuck. Because what's happening is we set a limit to the number of jumps, right? We said max jumps equals 2. Well, what's happening is he's reaching his max jumps, but his jump num is never being reset to 0. So what we need to do before the super gravity method, we need to say if dy equals 0, jump num equals 0. And what this means is whenever he stops in the y direction, he can jump again. So let's go ahead and hit run, start. This is a really weird path. Ideally, you would not put it to go this high, but you can see now that it's actually working, which is really good. I think that's all I'm going to cover in this video because I've already gone way over the amount of time I wanted it to be. Thanks for watching, guys. If you like my videos, make sure you like and subscribe. I definitely think one of the videos needs to cover the controls for this guy because I don't think they're very good yet. But anyways, see you guys next time.